The first searching algorithm we're going to talk about is jump search, which is an improvement to linear search. So it gives us a better performance, but it's not as fast as binary search. With jump search, we divide a list into a few blocks, and instead of checking every item, we jump to the block where the target item may exist. Then we'll do a linear search only in that block. So that's why we call this algorithm jump search, because it jumps to a particular block. So let's see how it works. Here we have an array of 10 items. First, we have to calculate the size of our blocks. We can mathematically prove that the ideal block size equals the square root of the number of items in the array. The actual proof is irrelevant, and as a software engineer, you really don't need to worry about that. So the ideal block size here is 3. So we can divide this array into 4 blocks. The first 3 blocks each have 3 items. The last block has a single item. Now, instead of checking every item in this array, we're going to figure out in which block the target item exists. Let's say we're looking for 23. We start from the first block. We compare the last item in this block with our target value. 6 is smaller than 23, so our target value definitely cannot be in this block. Now we look at the second block. Again, we compare the last item in this block with our target value. 18 is smaller than 23, so our target value cannot be in this block either. Let's look at the third block. The last item in this block is 24, is greater than 23, so if our target value exists in this array, it's going to be in this block. Now we do a linear search in this block. In this case, we don't have 23, so we return -1. That's the idea of jump search. So the maximum number of items we need to check is equal to the size of our blocks, which is the square root of n. And that means the time complexity of jump search is O of square root of n. Now let me give you a few hints before you start implementing this algorithm. We need 2 pointers, one that represents the start of the current block and the other that determines the start of the next block. So using these 2 pointers, we can tell what items exist in the current block. Now we need to advance these pointers using a while loop as long as the last item in the block is less than the target value. In this while loop, we need to watch for 2 edge cases. The first edge case is where start jumps out of the boundary of the array. That means we couldn't find a block where the target value exists in. So we should break out of this loop immediately. The other edge case is where the next pointer goes beyond the size of the array. For example, let's say we're looking for 31. With this while loop, start is going to be 9 and next is going to be 12, indicating that the last block may contain the target value. Now, when we do a linear search in that block, we'll be iterating items at index 9, 10, and 11. But the index of the last item in this array is 9, so our program is going to crash. To prevent this, as we advance the next pointer, we have to make sure that it doesn't exceed the length of the array. For example, if it becomes 12, we need to reduce it to 10. That is the length of the array here, okay? So go ahead and implement jump search. I will see you in the next video.